Today is the third part on circle and its properties. We shall discuss about subtended angles with hands-on activities. What are subtended angles? An angle is said to be subtended when the arms of the angle passes through the end points of the respective arc or the chord. Let us discuss with an example. Here is a circle and AB is a chord, and this part AB is the minor arc corresponding to this chord. We have joined point A and point B with the center O of the circle. At the same time, we have connected A and B with a point on the circumference of the circle, but on the remaining part of the circle. By remaining part, we mean the angle has been subtended by this minor arc or the chord in the remaining part of the circle. These are called inscribed angles. We can see that the arms of the angles at the center OA and OB are passing through the end points of the chord or the corresponding minor arc. Same way, angle AEB, the arms of this angle EA and EB are passing through the end points of this chord or the arc. These angles have been subtended by this chord or its corresponding arc. Children should take part in the hands-on activity individually. For the materials, each one should bring 4 to 6 cutouts of circles from white sheet, a geometry box, a color box and tracing paper as they have done in earlier activities. Each child should pick up a paper cutout of a circle of about 4 to 5 centimeter with the center marked prominently. This is the center. Now they will take 2 points on the circumference of the circle, and by paper folding join the center with each point on the circle. This is one radius, this is another radius, joining the center with the 2 points. Now they will take another point on the major arc of the circle. Now I am joining the end points with the point on the remaining part of the circle. Now they will mark these lines with pencil, just like this picture. So, A and B, let us write this is A and this is B, joined by ruler. AB is the chord and this part is the minor arc. Let us now join A and B . The center is O. joining A with the point on the circumference in the remaining part of the circle. Let us name this point E. So, this is one angle AOB, like this one, subtended by the chord AB at the center, and this is another angle AEB subtended by the same chord AB at the remaining part of the circumference. Now let them measure with tracing paper related size of angle AOB and AEB. Before that, they will color the angles. Let me measure this angle with a tracing paper. If we superimpose this on the angle subtended at the center is much greater than this angle. So, what can we do? Let us draw another angle of the size AEB to make the whole angle twice the angle AEB. Now this angle is double the angle AEB because we have drawn it side by side twice. Now if we try to match with AOB, superimposing the vertex of this angle with the center O, we can see the whole angle AOB exactly matches with the angle drawn by tracing twice the size of AEB. This is the angle AEB matching exactly with angle AOB. What does that mean? That shows that angle subtended by an arc at the center of a circle is double the angle subtended by the same arc on the remaining part of the circle. AEB is half the angle AOB, or in other words, angle AOB is double the angle AEB. Next, the children will take different points. Apart from point E, they will take other points C, D, F and G in the same segment of the circle and join those points with the end points of the chord or the arc, that is end points of the chord AB. Now what we get? We are getting several angles now. ACB by joining C with A and C with B. Then ADB, we have joined point D with A and D with B, forming an angle ADB. Same way AEB, AFB and AGB. These angles are called inscribed angles. Inscribed angles are formed when two chords intersect on the circumference of the circle. So now let us see the measurement of these inscribed angles on the remaining part of the circle. Why we are called remaining part? Because it is being subtended by this chord AB and this minor arc AB on the remaining part of the circle. So let us now see how are they related. This angle at C, D, E, F, G, how they are related. Let us see again with a tracing paper. Superimpose this angle on the other angles here, ADB. Let us superimpose this angle on ADB, matching the vertex D with vertex C. And you can see this angle is matching exactly with angle ADB. That means ACB and ADB are equal. Let's go to the next angle. Again, AEB is equal to the other two angles subtended at point C and point D. So are angle AFB and AGB. All these angles are equal. Children should do that with their own hands so that they can retain it. So now what happened? All these angles subtended on the remaining part of the circles at C, D, E, F, G, they are all equal. And we have already seen that angle AEB is half the angle subtended by the same chord or the arc at center, AOB. So we can easily see that all these angles inscribed on the other part of the circle, all these angles are half the angle subtended at AOB by the same chord, or in other words, angle AOB is double the angle subtended at C, D, E, F and G. Now we are going to demonstrate the same property with the angle subtended at the center by the major arc. The property remains the same, that the angle subtended at the major arc is double the angles subtended on the circumference in the remaining part of the arc. What does that mean? That means the angle subtended at the center by the major arc is double the angle subtended by the same arc on the remaining part of the circle, that is on the minor arc. What are these angles? AHB and AJB subtended by the major arc on the remaining part of the circle. These two angles are half the angle subtended at center, that is AOB. Now this angle is the reflex angle, as major arc subtends reflex angle at the center. Just to recapitulate, the angle that was subtended by the same chord and the minor arc was AOB on this side, and compared to that, this angle was less than 180 degree. But the angle subtended by the major arc at the center is more than 180 degree. If we place the ruler on OB, this part is the straight angle, that is 180 degree, and this part is more than 180 degree. This is a reflex angle subtended by the major arc. Now let us see again whether these angles are half the angle AOB. The children will pick up another circle with the center marked prominently and take 2 points A and B on the circumference and join. This is the center and this is point A and this is point B. Joining A and B to find the chord. by joining point A with O, so with center O. This is one radius. This is another radius. So now the angle subtended by this major arc is this one. Again we shall color this one red. Now we shall draw two angles subtended by the same arc on the remaining part of the circle. So we are taking one point at H, another at J. So H and J, and joining the end points of the major arc with the 2 points. So these two angles are subtended by the same major arc or chord AB on the remaining part of the circle, that is minor arc. And this is an interesting finding that these angles are both obtuse angle, that is more than 90 degree. These two angles are obtuse angles, and the angles subtended by the minor arc on the major arc, those angles were all acute angles. All these angles were acute angles that was subtended by the minor arc, and the angle subtended by the major arc on the opposite arc, all these are obtuse angle, and it is always true. Now let us measure these angles compared to the angle subtended at the center, and we expect this angle AOB to be double the angles AHB and AJB. So we are tracing the angle AHB if we join this angle with angle at J, we are tracing angle J adjacent to angle H. This is angle H, this is angle J, adjacent to each other. We wanted to show the angle AOB at the center is double the angle at H and angle J. We trace the two angles at H and J side by side, and let us see if it fits with the angle at AOB. It exactly fits. It may not show like this because I have colored a bigger part, but look at the angle. This is the angle, and it is superimposing exactly with AOB. AO, and this is part of OB, and this is our angle. That exactly matches the sum of angle H and angle J. So the same theorem holds true for the angle subtended by the major arc at the center and the angle subtended by the major arc on the remaining part of the circle. Now we are coming to the third part of the activity, demonstrating the same theorem. Here the radii AO and BO meet at the center. That means AB is the diameter, giving rise to two arcs that are equal in length. AB on this side and BA on this side are exactly equal because the circle has been divided by the diameter, giving rise to two segments. As we saw in the earlier activity, all angles in the same segment, this segment, all angles on a circle are equal. Same way, we can see in this diagram, the angle subtended by this arc AB at the center is this angle, which is 180 degree, because here AOB subtended by arc AB and it is a straight angle marked by blue color. This angle is 180 degree. The same arc has subtended angles at the other part of the circle. Angle APB by joining point P with A and P with B, and another one at Q by joining A with Q and then B with Q. So these two angles, as before, should be half of the angle AOB, because these two angles are on the other half of the circle. So let us measure that also, and because this is 180 degree, these angles should be half of 180 degree, that is 90 degree each. And this each half is also called semicircle. So angles on a semicircle are always 90 degree. Let us measure this with a protractor. So when we place the protractor on angle P, so this angle is 90 degree. You can see this angle is 90 degree. Same with angle at Q. We are placing the center of this line on the vertex Q. The angle is 90 degree here also. So angles on a semicircle are all 90 degree. On the other side, these angles have been subtended by this arc, and the angle subtended at the center by this arc has been marked with orange, that is also 180 degree, because it is a straight angle. So the angles at the other half of the circle subtended by the arc AQB should all be 90 degree. Again we measure with protractor, placing this point on the vertex. So this is also 90 degree. We have marked it with orange, and the other angle at R is also 90 degree. One arm of the angle, this is another arm, so this is also 90 degree. So angles subtended by an arc on semicircles are all 90 degree in measurement. For this activity, children should take another circle, fold it along the center to get the diameter to make two equal arc. These two arcs are equal. So angle subtended by this arc at the center is this one. We are marking it with blue. So how much is this angle? This is a straight angle, this is 180 degree. The same arc is subtending other angles at the opposite arc. So let us take some points on the opposite arc. Let us take one here and another here and join. This is one end point of the diameter. Joining this with the point here, and from the other end point of the diameter, so this angle has been subtended by this arc on the opposite arc. Let us measure it with a protractor. What do we expect? What should be the measure of this angle? As we have seen, the angle subtended at the center by this arc is 180 degree. We expect this angle to be half of the angle subtended at the center, that is 90 degree. Let us first give it a name. This is point S and this one is point R, and diameter is AB. So the angle subtended is ASB. We are measuring angle ASB. This line is matching with line segment SB, and we can see that 90 degree line is matching exactly with AS. So this angle is 90 degree as expected, which is half of the angle subtended at the center. And we color it the same color as the center. Angles subtended on the semicircle are always 90 degree. This is 90 degree, and if we join AR and RB, AR and RB, then we are getting an angle ARB. So this angle is 90 degree. Same thing will happen when the angle is subtended by this arc at the center, which is 180 degree, and on the other half of the circle, which will be 90 degree. These three activities demonstrates that angle subtended at the center is double the angle subtended on the circumference on the remaining part of the arc. Now with these two pictures, we shall demonstrate that equal chords or the corresponding minor arc subtend equal angles at the center. So let us discuss this one first, and students will actually do this on their paper cutouts. If this is the diameter and these are the equal chords, by folding the circle. So these two are equal chords that we have already seen in our previous video. These two are equal chords and they are at equal distance from the center. Now this is the center, and these are the two endpoints of the chords. We have to join the endpoints of the chords. If O is the center, let us name this angle POQ, subtended by the chord PQ or the arc PQ, minor arc. And same way, because these two chords are equal, so they should subtend same angle at the center. Let us join the endpoints. So with these two chords, hope we can see the chords. These two chords have subtended angle, let us name it MON, and this angle is POQ. This is one angle and this is MON, another angle. And if we again use the tracing paper, what happens? So I am tracing POQ. Children gets a lot of fun by using tracing paper to measure the angles. So this is one angle, POQ, and if we superimpose this on MON, vertex and the arms exactly match with each other. So this is the angle. MON is same as angle POQ. That shows equal chords subtend equal angles at the center. That is what has been demonstrated here. Now this picture also demonstrates the same theorem, that equal chords, these two equal chords subtend equal angles at the center. And with hands-on activity, we are taking two chords not exactly opposite to each other as we had done in our previous activity, but these two chords, equal chords, are at a different orientation with the diameter. So we have folded it along the diameter first, made it into two halves, and then folded two equal chords at one corner. And when you open it, it looks like this. Let us join these two endpoints with the center of the circle O. This is center. That is why marking the center prominent is so important. Let us say this is point A, point B. We are joining O with B. This is B. This is for this chord AB. AB has subtended an angle AOB at the center. And for this chord, we are joining this is another endpoint. Let us name this angle POQ, subtended by the chord PQ. So according to that theorem, AOB and POQ should be same. Let us again use the tracing paper. I am trying to trace AOB, angle AOB subtended by the chord AB. Sorry, not quite accurate. This is the angle. And if we superimpose this on POQ, this is PO and this is QO, the arms are exactly matching with angle POQ. So these two angles, AOB and POQ, are equal, and the students will mark them with the same color. These two angles have been subtended by two equal chords, AB, this is AB and this is PQ at the center. This is all about subtended angles for class 9.